Okay, so we're gonna create a histogram for the ages in a data frame here. And the first thing I'm gonna do is I'm gonna import some libraries. So from matplotlib, I'm gonna import pyplot, and I'm gonna give it the alias plt. And I'm also gonna import pandas, and I'm gonna give it the alias pd. So that should be something you're used to by now. And then now that I have those two libraries loaded, I'm going to use Pandas to create a data frame. So I'm going to call my data frame df, and I'm going to use Pandas read CSV method. So Pandas's nickname is PD, so I do PD dot, and I type read, and I'm using this read CSV method. So read underscore CSV, and then I'm gonna open a parenthesis, and the CSV I want it to read now, I have to go out and find it. I'm gonna put some quotations there, so you see the quotation marks, and I'm gonna come over and I'm gonna find the file. Here's the file I'm using, histogram raw data. That could be on your computer. You can find it on your computer by clicking this, or you could have loaded it from Google Drive. You click these three vertical dots and you copy the file path, and that's what you're going to paste over here. So that's what read CSV is going to take. You put quotation marks around the file path. That creates our data frame. Once we have the data frame created, we want to take a peek at it. So I'm going to do df.describe. And df.describe is just going to show me the 5-number summary and the mean for all the numerical data in my data frame. So when I do that, it gives me that there are 3 numerical variables in the data frame. It gives me the count of each of those numerical values. So there's 193 values for each. It gives me the mean for heights, the mean for weights, and the mean for ages. It also gives me the standard deviation for those 3 variables, and 5-number summaries, which include the minimum, first quartile, median, third quartile, and maximum for all 3 variables. I'm going to go ahead and create a histogram for ages. So to do that, I'm going to add another code cell down here, and in this code cell, I'm going to type in the code for the histogram. Now the library I'm going to use here is pyplot from matplotlib, and remember its nickname, its alias was plt. So I type plt, and I'm going to use the histogram method. So plt.hist, that's the histogram method. This one here, the histogram. And then it takes a couple parameters. The first thing it's going to take is going to need to know what data is going to make this histogram from. So we have to tell it which variable we're using. The variable we're using is in df, that data frame df. I'm going to open a bracket to tell it which variable I want within df, and then put quotation marks to let the program know I'm looking at one of the variables in df. The variable I'm looking for is ages. Ages. So this is df ages. That's the data or the variable that I'm going to create this histogram for. Then I need to tell it the number of bins I'm using, or the number of classes. So bins are classes in Python. I want to create 7 bins or 7 classes. And then the last thing I want to do is edge color, so that the rectangles that separate each class actually show up and it's not just one big blob. So I'm going to give it an edge color, and I'm going to make the edge color be black. So edge color equal, in quotations, BLACK. So the edge color is black. So I'm using PLT, which is pyplot. I'm using its histogram method on the ages variable in the df data frame. I'm going to create this histogram with 7 bins, and the bins, the individual rectangles, will have black as their edge color to differentiate them. When I run this, it gives me this histogram with 1, 2, 3, 4, 5, 6, 7 bins. And it also gives me actually this frequency distribution up here. Alright, so that's how you create a histogram using Python. You'll notice that this histogram, it makes it seem as though the data of the ages actually is skewed to the right, because the data starts off high, starts off with a lot of data in the first class. Then as the classes increase, as the values increase, you get less and less large values. So it looks like this data would be skewed to the right.